All right, we are on, let's go up here, section 13.3 today. There we go. So let's type that in here. And again, we're still talking trig. I'm just going to start off with an example. It's example 1 is on page 825 if you want to look at it. Let me get a little x and y axis going right here. Make it a little bit bigger. And let's put an angle on here. I'm just doing the one exactly from the book. It was like, actually, I tell you what, before I do that, let's read the problem and see what it says. It says the terminal side of theta. Are you looking in? I mean, if you want to look in the book, it's on page 825. The terminal side of theta in standard position contains the point -3, -4. All right, so that's what we're going to write. Now, why did it do that? There we go. So -3, -4. So basically, the line that forms that angle, okay, you know it comes from the origin, comes out like this. It contains the point -3, -4. So what are we going to do? We're going to graph -3, -4. So there's 1, 2, 3, 1, 2, 3, 4. It doesn't have to be exactly to scale, but that's pretty close. All right, so there's the point -3, -4. And it says the angle contains that point. So what we're going to do is we're going to go from the origin and we're going to just draw a line so that it goes through that point right there, -3, -4. Is that okay? Let's just change it to a different color. All right. So we've got this angle right here. And the question says, find the exact values of the 6 trig functions of theta. The 6 trig functions. Let me shorten this up just a little bit. Actually, I'm going to take it right to that. Now, it says it goes through it, but I'm going to just take it right to it. So what we need to do is we need to write the 6 trig functions, sine, cosine, tangent, and then we're going to do the cosecant, secant, and cotangent of those things. But first of all, we need to see what angle that we're dealing with here. So remember how we label this angle. We don't just label it right here, even though we are going to talk about this angle in a second. But really, what angle are we referring to? We're referring to this angle right here, aren't we? Whatever that is. They're not even asking you to find what that angle is right now. Eventually, I doubt in this lesson, but I think in another lesson, they will ask you to find this. And in fact, we may just do it anyway, even though they don't ask you to find the actual angle. They're only asking you to find the sine, cosine, tangent of the angle. They're not asking you to find the actual angle. But we can do it just for fun, okay? So let's get rid of that, and let's do this. First thing I'm going to do is I'm going to make this look like a triangle, okay? So I'm going to start right here, and I'm just going to take this, I'm going to drop it up to the x-axis. You could always take it to the y-axis, but I'm going to be just consistent on this, and I'm thinking of something that we're going to do a little bit later on. Now pretend that actually hits right there, okay? You get the idea. So now we've got a nice little right triangle right here. Let's put the right angle, because we've got a horizontal and a vertical, and let's just talk about this angle right here. All right? Because we're going to do the sine, cosine, and tangent of this triangle right here. Okay, so this is the theta that we're going to deal with. So let's write down, it doesn't really matter, I guess. Let's go sine, then the cosine, and then the tangent. Now, once we find sine, cosine, and tangent, the inverses, the other 3, are really easy to find, aren't they? Because what do? All you do is just flip them. Okay, you just take the inverse of them. So the sine, cosine, and tangent, we'll find that here in a second. And then we're going to do, what's the inverse? Do you remember what the reciprocal function is of the sine, the inverse function? Those weird words, which one is it? Yeah, what's the word? How do you say it? What is it? Cosecant, right. Because sine and cosecant are inverses of each other. Whoops. You just told me, Allie, and I didn't write it. Okay, there we go. Cosecant of theta. And then what's the inverse of the cosine? The secant, good. And then the inverse of the tangent. That's the easy one to remember. That's the cotangent. Everybody okay? So it's not really that hard. It doesn't take that long to do. But where's some numbers? This doesn't even have any numbers at all. How in the world can we put numbers in here? Well, it's not that hard because we know what this point is. This point is -3, -4. So that means from here we went out how far? Yeah, and we went -3. Now we do have to consider the sign, all right, because of what quadrant we're in. Now from here to here, how far down did we go? If we're at, yeah, we went -4. That's easy to see, isn't it? Now what's this hypotenuse going to be? You can do this without even doing any math. It's going to be 5, isn't it? Now the hypotenuse, it's always going to be a positive, all right? We'll never make it negative. You can only go positive and negative along the horizontal and the vertical, okay? So this one will always be positive. And now we can just look at this and just put the stuff in here. So the sine of theta, the sine is opposite over hypotenuse. So give me some numbers here. -4, say it. Good, -4/5. So that's the sine, -4/5. While we're at it, let's just do the cosecant. What would the cosecant be? Yeah, and does it matter where you put the negative? No. I don't know. I like to either put it on the top or out front. I didn't leave myself room to put it out front, so I'll just keep it on top. You okay with that? All right, we just flip it. It doesn't matter where the negative is, on the top or the bottom. Let's do the cosine. The cosine of this angle is adjacent over hypotenuse, so this is going to be -3/5. Let's do the inverse right away, and that's just -5/3. So even though they ask you to do 6 things, does it really take that much time? It really doesn't. It's not that hard to do. So the tangent of theta is opposite over adjacent, so it's opposite, -4 over adjacent, -3. So let's just do that in our head. What's negative over negative? Positive. So don't keep, I've seen that on tests and quizzes where you get a negative over negative and you keep it like that and circle it. Okay, don't do it. It's not wrong. I don't mark it wrong, but it's just not the best way to write it, okay? So if it comes out negative over negative, write it as a positive, all right, because it is a positive and it's simplified that way. Some teachers might even take off for that because you didn't simplify it. I don't know personally, but they could. And of course, what is the inverse of that? That would be 3/4. Everybody got that? All right, that's the first thing that they have you do. That's not that difficult at all. Okay, we're going to talk about a thing, they call them quadrantal angles. I hardly ever refer to them as this, but I guess some people do. It's in the book. So quadrantal angles. I mean, I use these all the time. I just never remember referring to them as a quadrantal angle. But we will talk about this here. Let's actually do 4 of them. Put this right here. Put that right there. Okay. Let's go to this first one. And I'm just going from the book. Let's just do it right here. What if, when we talk about the quadrantal angles, we're talking about these main 4. That's why I put a little XY axis here, because we're talking about the angle right here. So if I went from there to there, how many degrees is that?
0.
It's 0 degrees. Let me just put a little line just to kind of, and I'll tell you what, let's make it a little thicker just so it stands out a little bit. So if I go from here to here, can you see that? Yeah, you can see that. So right there, that's 0 degrees, isn't it? That's one of our quadrantal angles. Okay, it's really not that big of a deal. Now, what would that be in radians? 0 radians. That's easy. Okay. Let's go to the next one. The next quadrantal. I mean, we're talking about the big 4. Okay, if you want to talk about that. So, what do you think this one's going to be up here? Yeah, it's going to be 90 degrees. So 90 degrees is the same thing as, do you remember what that is without even looking? Pi over 2, good. All right, so it's pi over 2. So let's just, and we're going to use these a little bit later on. I'm not sure exactly what they're doing right now. I think all they're doing is just making you aware that these angles are there and we're going to use them quite a bit. They're really not doing much with it. I guess that's all they're doing right here. Oh, okay, I see what they're doing. We'll do an example after this is over. So let's do this before my time runs out here. Obviously, what would the other one be? Oops. Yeah, it'd be 180. So right there, and then this one would be 270. Let's write that on there real quick here. So that's 180. What's my radian? It's pi. and this degree angle is 270, and my radians would be 3 pi over 2. All right, let's move on. Let's stop this one. We'll go to the next.